Hello! Today we're going to do some cool stuff. We're going to do mathematics, and I love me some mathematics. This is the second part of the lecture on how to represent ideas in solving problems. And in this part we're going to have a look at how mathematical models help you solve problems. Also, mathematical models really are good in communicating the solutions of problems. Because you might not have thought about it, but math is totally unambiguous and crosses all cultural and language barriers. And as always, do not hesitate to pause the video whenever you need it. Mathematical sophistication to some degree is required for any problem solving. You do not really need to be a mathematician, but you do need to be able to recognize abstract mathematics in real-world problems. Once you have recognized the math, you can define the problem as a mathematical model. A model is a set of concepts that represents a problem and its properties. Models help us solve problems. Creating models is so important that it was, or at least should have been, the main goal of mathematics and physics in school. Mathematical models have a great advantage. They tend to be easily converted into programs. They also unambiguously communicate your ideas across cultural and language barriers. So, let's have a look at a typical school problem. Now this problem is also listed in the book, Computer Science Distilled, so you can always read more about it there. Assume that you are a farmer. You have some sheep, some cows and 100 meters of fencing material. You need to create a rectangular paddock with a separation so both the cows and the sheep can stay in it without mixing. The problem is how to set up this paddock using your 100 meters of fencing material in such a way that the total area of the paddock is as large as possible. Now feel free to pause the video and think about this problem. Okay, here's how to solve this. What do we want to know? We want to know the length L and the width W of the paddock. L times W is the area A of the paddock. We want to maximize the area. That means that we want to use all the fencing material we have. With these insights, we can relate L and W to the 100 meters of fencing material in this way. A is L times W. The area is the length times the width. The 100 meters of fencing material is 2 times W plus 3 times L, or the other way around, but I'm choosing this way. And graphically, that will look something like this. So, what do we have? 2 times W in fencing material, 1 and 2. And we have 3 times the length, 1, 2, and 3. Now, the sum of all those bits of fencing material should be 100. And the area, of course, is L times W. From this follows that L is 100 minus 2W divided all by 3. And then we can replace L in the first equation and we get area expressed only in W. And that's this equation here. We can write that more clearly as follows. A is 100 divided by 3 times W minus 2/3 W squared. Pause the video if you need to do some algebra to see how this works, but it is pretty simple this. Now this should look familiar. It is a quadratic equation, and that means a parabola. And we want to find this point, the orange point here. By the way, if I write something in orange, that means a result of some sort. One way is to find the roots by setting the area to 0 and solving the quadratic equation. We can find the green points here. And once we have those, we can select W in between them, because exactly in the middle will be the orange point, the maximum of the area. Now, I would be very impressed if you still know how to solve a quadratic equation just like that. You do not need to know it. The smart stuff is already done. The rest you can look up on the internet. But by being a little smarter still, we can easily find the answer. The trick in this case is to multiply with 3 divided by W, as I've done here. Now, from that it easily follows that 2W equals 100, and that W is 50. Well, that's one root. The area is also 0 if W is 0, obviously, so that's the other root. The point we need is W is 25. Now, the formula for the area has a maximum value when W is 25. Now, setting W to 25 in the formula for L will give us L is 50 divided by 3. The maximum area is then 50 divided by 3 times 25, which is 416.666 square meters. Now, that's that one solved. But we can be even smarter than that by using calculus. But that may go beyond your high school math. But I will demonstrate it anyway. Remember the quadratic equation? Well, the area A is a function of W, and the assignment was to maximize A. So really, we need to find the derivative of A with respect to W, and set it to 0, as I've done here. The derivative of A with respect to W is 100 divided by 3 minus 4 divided by 3 times W, and we set that to 0, and that will give us W is 100 divided by 4 is 25. Well, that was way more easy. Bob's your uncle. So let's summarize. To solve the problem, we had to recognize the relation A, that the area is the length times the width, and B, that 100 meter of fencing material can be expressed in the formula 2 times W plus 3 times L, because we have to divide the paddock into 2 separate bits. From there we deduce that the area could be expressed only in W, and that was a quadratic equation. The largest area we can find was W is 25. Now we have everything to create the mathematical model of this problem. We found that for any amount of fencing F, W is F divided by 4. From the formulas for the area and the fencing material, it follows that the length is F divided by 3 minus F divided by 6. Is F divided by 6, F being the amount of fencing material. So the paddock has a maximum area, A max, of F divided by 6 times F divided by 4. Now let's formulate the model. I'm not going to read it, you can read it. Well, that's it, we're done. And I guess you are too now. What I want you to take away from this is that some mathematical sophistication really helps you solve actual problems fast. Now pause the video and write a function in pseudocode to design a paddock with a maximum area that only has the amount of fencing as its parameter. This should demonstrate how easy it is to create code from mathematical models. Okay, once you've done, you should have something that looks like this. Can be different, of course, but you will understand if you had it right or not. I created a function with an annoyingly long name, design paddock with max area, and it takes a parameter called fencing length. Now, first we initialize a variable L with fencing length divided by 6. That is this one. Then we initialize W with fencing length divided by 4, which is this one. Now, then we simply print the length and the width, and then we can calculate the area by doing L times W. And that is this bit. And then a hypothetical output of such a program would be something like this. Well, I hope you enjoyed it. In the next lecture, we're going to have a look at logic. So, see you in the next one. Bye-bye.